The first example we're going to look at in this video is what is the concentration of barium 2 plus and hydroxide minus ions in a 0.20 molar barium hydroxide solution. And when we look at this, we need to think about the individual barium hydroxide molecules and what they're going to look like. So if we have barium hydroxide, for every one barium ion, we have 2 hydroxide ions. So this molecule is going to look something like this. If we dissolve this in water, it's going to break down into one barium 2 plus ion plus 2 hydroxide ions. So notice that the number of hydroxide ions is going to be twice as much as the barium ions, or you're going to have twice as many moles of hydroxide ions than you would of barium ions. So this is going to influence our concentration. So initially we're going to start with 0.20 moles of barium hydroxide per liter. For every 1 mole of barium hydroxide, or BaOH2, there's going to be 1 mole of barium 2 plus. So since we have a 1-to-1 ratio, that means that we have 0.20 moles of barium 2 plus per liter of solution, or we can say that our concentration of barium ions is going to be 0.20 molar in barium 2 plus. So this might not look like too much of a difficult calculation, but there's going to be some significance when we look at the hydroxide. If we have 0.20 moles of barium hydroxide per liter, for every 1 mole of barium hydroxide, there are 2 moles of OH minus. So this is going to give us 0.40 moles of OH minus per liter of solution. That means our concentration of hydroxide ions are 0.40 molar in OH minus. So this is going to be significant when we look at the stoichiometry and how these ions come together in solution. So make sure you're using the proper conversions and you're writing out everything and using the correct dimensional analysis. Another example problem we're going to perform is looking at how we would prepare certain solutions. So how would you prepare 250.0 milliliters of 5.43 molar NaCl? So how would we prepare this solution? So if we are preparing 250 milliliters, when we convert that to liters, it's going to be 0.2500 liters times 5.43 moles of NaCl per liter of solution. We know that for every 1 mole of NaCl, we can look at the periodic table and determine that that's 48.44 grams of NaCl. This gives us a value of 79.3 grams of NaCl. So typically we use something called a volumetric flask in order to perform this, or to prepare this solution. So in a volumetric flask, we typically have a flask that looks something like this, with a long skinny neck and a line just like this in that glassware. And if we're using a 250 milliliter volumetric, we can first dump 79.3 grams of NaCl into this flask and then fill to the 250 milliliter mark with water. And this is how, in most cases, we can prepare these types of solutions that you will use in your laboratory experiments.